Well, we have a question here that says in the diagram below, in the diagram, PR is perpendicular to TS in obtuse triangle PTS. PT is equal to square root of 5, TR is equal to 2, and then PR equal to 1, and then PS is equal to square root of 10, and RS is equal to 3. Now we're going to do question 5.1. Question 5.1.1, excuse me, and question 5.1.2. Now let's do 5.1.1a says we need to write 5.1.1 says write down the value of a is sine of t. So sine of the angle where t is. So this basically this angle. Then we know from the definitions or formulas of trig functions, sine of an angle theta, okay, is equal to opposites over hypotenuse. So like opposite the angle over hypotenuse. So y is like the opposite, the angle, and then r is hypotenuse. Okay, so we need to find that. We're just gonna use this formula. I'm gonna say sine of the angle t will be equal to opposite the angle. Opposite the angle is actually this side, and then hypotenuse is the longer side of the triangle, so this one is the hypotenuse. Square root of 5 is the hypotenuse, so this will be opposite is 1, and then hypotenuse is root 5. So we can write that, or we can someone can also rationalize this. So this is the equivalent to say 1 times root 5 over 5. It's the same thing. Okay, so maybe how did I rationalize this? It's like I did square root of 5 is here. Okay, let me show my work. We have like 1 over root 5. So what I do here is like I times here by root 5, and I times that also by root 5. And then this will make root 5 over 5, root 5 over 5. So we can stop, but I prefer to stop here. Okay. Just all right. Same also, we have like question 5, question 5.1.1b. Okay, says I want to find cos of S. Okay, so from the trig functions, we know that cos of an angle theta is equal to x over r, so which is opposite the angle. Excuse me, adjacent to the angle. X is adjacent to the angle, and then r is the hypotenuse. Okay, so this will be then cos of S, the angle where S is actually this angle. So adjacent to the angle is this side is adjacent to the angle, and then hypotenuse is just root 10 there. So we're gonna do cos S will be adjacent, which is 3 over root 10. Okay, so that's cos of S. Someone may like to rationalize is when we do cos of S will be equal to 3 over root 10. So it's like you times here by root 10, the denominator, you times the numerator also by root 10, and then this will be 3 root 10 over 10. But we prefer to stop by here. Okay, I prefer to stop here. And then question 5.1.2, the question says calculate without using a calculator the value of cos t plus sine S. Well, I'm gonna write here question 5.1.2. So we are looking for the value of cos of t plus S. Okay, angle t plus angle S without the help of a calculator. Okay, we have like a compound angle here because we have like this is like a sum of it has sum of 2 angles S, T and S. Now what I'm gonna do, we're going to apply the compound formula, the compound angle formula. For we can reduce it this way. We know that cos of A plus B. Okay, this is equivalent to say cos A times cos B. Okay, when it's plus, we're going to place in minus. Okay, minus sine A sine B. That's the compound angle formula for cos. So this would be like cos A. So cos, in this situation, we're gonna do we have like cos T plus S then. Okay, we are going to do cos T, okay, times cos S minus sine T sine S. So I prefer to move my board this way, and then I'm going to just split the board like that. Okay, so now I'm gonna do cos S. Okay, let's just say T plus S. It's the same thing, but I prefer to just follow as it was given. Cos T plus S. This then will be equal to cos T. Okay, let's see what is cos of the angle T. Okay, we did say here cos is like adjacent over hypotenuse. Okay, so cos T is over here, adjacent to the angle T is 2. Okay, this is adjacent, and then the hypotenuse is √5, so we can just substitute there and then say 2 over √5. Okay, and then times cos S. Okay, cos S is over here, adjacent is 3. Okay, and hypotenuse 10. Actually, we did work out cos of the angle S over here. It was 3 over √10. So yes, we can just substitute this value over here. So this is going to be times 3 over √10, 3 over √10 minus sine T. Okay, so sine T was calculated here. It's like 1 over √5. So we can just substitute this value there. 1 over √5, 1 over √5, and then multiply by sine S. We can just look here. Sine S, it's opposite over hypotenuse, which is √3. Excuse me, √10, 1 over square root of 10. So this will be multiplied by 1 over square root of 10. Now we can do the calculation here. 2 times 3 is, so when we have a product, when we multiply fraction, we times the numerator, we times also the numerator. Okay, so this will be 6 over, okay, √5 times √10. We are allowed to do square root of 5 times 10 because they both have same indices, which is 2. They both have indices 2. And then minus 1 times 1 also is 1 over √5 times 10. Okay, this means this makes like 6 over √50, square root of 50, square root of 50 minus 1 over square root of 50. Now we notice that the numerator here are common. Okay, they're both square roots of 50, so we can just subtract the numerator. Okay, we can just do 6 minus 1, which is 5. So like 5 over square root of 50. Then square root of 50 can be, it's like square root of 50 is like 25 times, we can break it up like this. It's like 25 times 2, isn't it? Okay, over 5. And then this is like 5 over √25 times √2, like that. Okay, and then √25 is just √25 just 5, so it's like 5 times √2. So we can simplify here again. Okay, we can just cross 5 and 5 there, and then we have left with 1 square root of 2, 1 over square root of 2. So which can be further rationalized to like 1 over square root of 2. If we times here by √2, there also by √2. Okay, and then we will get √2 over 2. So therefore, we can say cos of T angle T plus angle S will be equal to 1 over square root of 2 or square root of 2 over 2. So this is the final answer here. Thank you.